There we go. Yeah, I'm alright. Okay. Anybody who doesn't know me, I'm Kevin Fielding. I'm practice BIM lead at Sheppard Robson. I'll crack on and rattle through this. Make sure we're not too far behind with the breakout stuff later on. This is us. We've got 3 offices across the UK. It's about 360 of us in total. We've been going for about 80 years, quite a while. Work across a whole bunch of different sectors. I'll skip that bit. Okay. So what I'm talking about today is door libraries, how to build one, and let's see how we go. So you can go out and source door libraries. It may not be the best solution for you, but it depends where you are in terms of practice, in terms of your development. Hopefully we'll get an idea of that a little bit later on. You could go to somewhere like BIM Store. They have good quality content, very much kind of manufacturers orientated. BIM Objects as well also provide doors that are available. MBS, or the National BIM Library. Again, I think where the National BIM Library differs from the others, they also have some generic content as well, which is quite good. But it's kind of one of the issues with this kind of stuff is, well, one of the good things is that it's free, freely accessible. It's high level of detail, so there's a lot of kind of manufacturer stuff with hinges on and push plates, ironmongery, all that kind of stuff. It's rich in manufacturer's data. It's got loads of Kobe data in there. It's got all information about specifications, and it's complex as well. Okay, so looking at these kind of benefits, oh yeah, and also that they're instantly available as well. You don't have to go out and tell somebody in your office to go build it. You can just have a look on the website and see what they've got. But for me, these 4 are also probably one of the downsides as well. That it's too much detail. There's way too much data than you actually need on a regular basis in your office. It's difficult to edit because everything's inside one file, and you are limited to what other people have already made you. So if you don't have the abilities in-house to build this kind of stuff, you're kind of scuppered. There are other ones out there as well. Anybody actually use these? Or ever? Thankfully nobody put their hands up. This is where you have one family, and then this family does pretty much everything. It does single, double, bifold, all these different vision types. Personally, I wouldn't touch one of these with somebody else's barge pole. They're far too complex, and from what I've seen as well, the amount of parameters in there makes it virtually unusable to the everyday user. So looking at the demand, kind of what we need to do when you're actually building the library, there's multiple different types that you might be interested in. Let's see if the lasers don't work on screens. You have like curtain walls at the top. You have your wall-hosted ones in the middle, and then you've got potentially unhosted ones as well. So depending on the kind of nature or how you're going to implement these. So you've got suddenly, before you even start, you're dealing with like 3 different types of door, and then you end up with subtypes where you've got internal, external as well. So the numbers ramp up quite quickly. There you go. So another thing to consider as well is the maturity of the staff that are actually going to use that information and the data. So this is, we rate all our staff in terms of their skills. So this is something that that came up from a couple of months ago, something like that. We kind of rated our staff and based on kind of where we were at, and we saw that across the practice we had like different skills. Different offices had different levels of ability, and we had to take that into account. If we've got very low levels of skill in certain offices, it becomes a bit of an issue. So there is a video here, but I don't think it wants to play. Oh, there you go. So it also needs to be kind of parametric. So kind of what sort of things are we looking at? So we need to adjust the leaf, architrave size, shapes, the swing, the frame, visibility. You need to be able to control. So all this is just kind of flicking through some of the parameters and some of the kind of flexibilities of our standard doors. Side lights, different openings if you've got those kind of stuff. The materials, all these you need to consider how you're going to actually control these when you're building your projects or you're building your families. So the level of detail is very important. Now it needs to be stage appropriate. Obviously this will have an impact on file size as well for the individual bits of content, and also will have a significant impact on model performance. This isn't one of our doors. This is something that has come from one of the libraries that I showed you earlier on. But I'd only really use this, if at all, like stage 4 or midway through kind of stage 4 once I have a clear understanding of what it is. But majority of the time we don't even go to this level of detail or anywhere close to it. Primarily because our design responsibilities, we tend not to exceed. In terms of the geometry inside the model, probably what you consider like an LOD 3 or 300, which is kind of a general level. We're given a like impression of the geometry, something that would be suitable really for kind of a 1 to 50 or above. So we typically don't tend to go into this level of detail. We've got these kind of hinges, and you've got the closer as well. It doesn't really add value to a lot of our drawings. Maybe there might be 1 or 2 instances for external elevations, that sort of thing, but in majority of instances we won't go anywhere close to this. So this is more appropriate to kind of what we deliver or what we build on our projects. We have a very simple representation, as I said. It also doubles up with a low level of, this is representation in a low level of detail in plan as well. So we have low, mid, and medium and detail, which are both, or medium and high. Those are kind of combined together. So we kind of keep, when we've got like a 1 to 200 or something like that, we can pull back the amount of information that we're actually showing on the screen. Improves performance as well. So when I can make this bigger so I don't have to keep looking at that screen. That's better. Okay, so again, it's about understanding what you need from your door libraries. You certainly, from our perspective, we want something that's very flexible, that will fit all our scenarios. It needs to be easy to use. You need to have a wide range of content to use across all your different project types. For us as well, we want to be able to support IFC as much as reasonably possible. We want to embed the classification information in there to reduce the amount of rework or the amount of additional work that people have to do on their projects, and also minimize the number of parameters that are actually visible to the users so the content becomes easy to use. So when we're looking at this kind of stuff, this is the way our kind of content is broken down. It's broken down based on kind of a granular approach. So every piece of content has an architrave element in it, swing, frame, leaves, clearance zones, and threshold, not necessarily thresholds. Those are dependent on particular types. So with all those different subcomponents, the question is to nest or not to nest content in there. Now, by that I mean when you load a family into another family, it's nested within there, and there's an option to have something called a shared nested family. So that means when you load a family that has a nested element into the main project, then the nested element is selectable inside the project. There are pros and cons of that, and I'll talk very briefly about that. So there's essentially 3 ways. Do you build everything inside one family? Do you nest it and use this shared functionality? Or do you say, actually, I'm not going to have it shared and I'm just going to load it in? Okay. So looking at those at the options, we kind of just put together this table really, which is kind of a bit of a matrix of kind of the feedback. So if you're dealing with kind of all-in-one, complex families, they're very difficult to edit. Repetitive updating, if you've got everything inside one file, you have to make the changes in every single kind of door in your library. The file sizes are smaller, which is good. But when you start looking at kind of nested content, you start seeing the scalability. I'll demonstrate this a bit later on. You have to manage, one of the drawbacks is you actually have to manage the nested content that you've got in there. But updating it can actually be really efficient if you've got the right tools. If you're using shared nested components, it gives you additional in-project flexibility. You can switch them out actually in projects and locally, which is quite interesting. The file size inside your project is significantly reduced. You can schedule the subcomponents if you actually really need to or want to. So if, we don't really have the need for that. We're not really interested in scheduling our frame types or architraves, but perhaps somewhere down the line, or depending on the type of practice that you work at, something like this might be appropriate for you. Or even if you don't work in architecture and you work in a different kind of field, then the ability to schedule subcomponents might actually be quite useful. Big issue for me is the issue of exporting. You're exporting to IFC and Navisworks. When you use shared components, those objects exported separately. So if you have a door, for example, and you have a nested leaf, the leaf comes out as a separate door. So just be wary of that. And tagging can be a bit of a pain. You don't know which one you're actually tagging, whether you're tagging the shared nested element or the actual content itself. And for the not shared stuff, increasing file sizes is a bit of a negative. So we actually decided to go for the not shared but nested approach, and this is kind of how we get it to work. So the main door becomes a container. There's actually no geometry within there, and then what we have is separate families for each of the parts of the door, and then this is loaded into the container. It means that you can swap these out quite efficiently when you're building the families, and I'll demo that. So once you've got this approach where you're building these individual parts, and you build essentially kits of parts, so you build 50 odd different types of leaf and different types of frames, different swings and all that kind of stuff. You start off with a seed family, or you start off with an initial family. So right at the very top there, the very first one that I built was a single swing blank door, kind of the very kind of basics. So that was the absolute beginner. So for that, I loaded all my data in there. I added my functionality for door swings and visibility controls and stuff like that. And from that, I was able to create different variations, different leaf types, and etc. But that one also becomes the seed for the double. So from that, I added functionality to control like 2 leaves. And then from there, it also became the seed for things like bifolds, slightly more complicated variations as well. And from the double, we get unequal, and then we get unequal, and then we get like double bifolds as well, and then you get the subtypes of the doubles and so on. But the majority of the principles that go into building the single door also goes into building the single door, and also the components as well goes into the single door for the curtain walls as well. So by using a modular approach of having different elements, you can actually load them in And the key ones really are whether it's wall hosted, whether it's curtain wall based, or whether it's unhosted. Those are kind of your starting points, and from there it kind of filters down into these different types. So you've got doubles, you've got your specials, which are kind of built off the back of these, and then you've got your kind of subtypes again. So you can see very quickly how this can kind of escalate. But once you've got your kind of seed families, you can build your subtypes really quickly. So give you a quick demo of some of the one of my doors. Right, so what we have here is a double. Oh no, we don't. Sorry. Let's. There you go. It's not just me on my own now. So what we have here is a double door. If I click on any one of these elements, you can see that it's a nested family. Just open up one of these, you can just have a look. So this is nested family. It has its own controls in its own right, controlling things like swings and various bits and pieces. And then we've got a leaf family, which is in here. Yeah, that's all very nice and good. And then we've got other kind of bits and pieces as well. We've got architrave and we've got the frame. So if I was to delete all the families that are loaded within here, all you'd have is actually, let me just go ahead and do that in this view. Go back to plan. All I have is some reference points, and that's all that's actually sits inside this family. So within our library, we don't build every single permutation or every single door type. We actually only build essentially the minimum number that people kind of need to use. There's a few extra ones. The reason why we do that is I'll show you now. It's quick to build new types, but it makes maintaining them a lot easier from our perspective. So if I want to change the appearance of this door, I don't have to worry about having prior knowledge in family creation. We provide all our users with a very simple guide to show them the process of creating new door types. So all they have to do is go into our library of leaf types. They'll just load these in, and let's just pick that one as an example. So that just loads in an extra leaf family type down here. Select these, and then come into my type selector and switch these out. Okay. I'm sure that wasn't a good warning. Right, there we go. And then there's some settings that you might want to change just to make some slight variations. So, and then what they would do, they would just come into the type settings within here, and then just change the description, save it, and then they've got a brand new door type. Pretty quick, pretty simple. So a lot of the kind of legwork was in the actual building of these individual families, and then all the control kind of happens in here, so it makes it as easy as possible for the guys that are actually working with these on a daily basis. It also means that the BIM team don't have to be called every 2 minutes when everybody has the bright spark idea of trialing a new door in their projects. All these objects, let's pick the frame as an example, all these objects have associated parameters for things like sizes and materials. So you can see everyone that's kind of greyed out on the far left hand side has an associated value. Now all these parameters that are in here are shared parameters. That means it reduces the issue of when we hot swap these out, that those parameters still stay associated with the ones inside the family. So if we look here, we've got things like structural opening, and then you go inside the family. This is the main bit that people see inside the projects. You've got your structural opening parameters down here. So no matter what frame I switch out or what leaf I switch out, all those settings are automatically controlled by the family or the host container. So we have all different kinds of functionality. You saw before that we kind of changed the. Let's just load this into a project. Any burning questions just while I do this? Nope. And tip as well is build them in the earliest version that your projects are working in. All our libraries are currently built in 2017. That way you don't have to worry about telling people in the office that you can't have the doors because you're not working on that version of Revit. Okay, so I did obviously that video before that showed stuff flexing and bits and pieces, like covered all the parameters and whatnot, but we have, let's just go to plan and show it there instead. So we control the architraves, we can turn those on and off, we can control the positions of the frames, and all these inside the family is just controlled by formulas and bits and pieces, and then we've got things like angles and stuff like that. So some of the formulas are embedded inside the nested families, and then we have a section here that has formulas that are controlling some of the more complicated stuff that we need inside the families. What I have found over the years with experience is if you have nested formulas inside, or if you have formulas inside nested components, it does slow the families down. So I try to keep as many of the formulas as possible at the highest level of the family. Okay, just while I'm here as well, so we keep all the materials in here as well, IFC parameters, so and then some of the IFC information such as opening styles, whether it's double or single. This is all driven by other parameters inside as well, so you don't have to worry too much about getting the guys in the office to set your opening your IFC door operation, because you know for the majority of them they don't care about IFC one bit, which is a bit of a shame, but hey ho. So we can control a lot of that, and then what we're trying to do now across the practice is get people to use the IFC parameters instead of kind of creating their own instead. So because a lot of the default IFC parameters that are in, like IFC door common as an example, will be sufficient for a lot of the purposes. Things like acoustic rating, basically everything that you see on there you would normally show within a schedule, and those are all IFC parameters. So I'm not going to go into that. There's presentations online if you want to know more about Revit and IFC parameters. Okay. Right, so our library currently consists of 46 different frame types. So we've got things like pocket doors and overhead doors, different styles, and we've got ones with louvers in and whatnot. We've got 60 different leaf types, some with ironmongery, you can see a few up at the top, and then we've got a whole bunch of arrays for louvered ones. Swings, so I opened one of the ones earlier on, one of the standard ones, but we've got slidey ones and bits and pieces. These have built-in clearance zones as well, so when we export out to Navisworks, if we want, we can turn those on. The more sensible option is to use something like Celebri and use the clearance opening distances in front of openings functionality. Ironmongery as well, 20 different types. So when you kind of put all this together, you've got like well over 100,000 like permutations that you could possibly use, or different kind of families that you could build. That's not even before you get into the actual types of the sizes and stuff. And then our library currently consists of 190 different types, like curtain wall and external, internal, wall-based. So we're quite a bit short of the 100,000 there, but to be honest, that's enough for the majority of instances that we use, and any bespoke ones people can just build on their own projects. So so the key principles basically of what we've kind of built is keep the number of parameters inside the actual family or the container as minimum as possible, so it's easy for the guys to use. Like I said, I've seen these all-in-one contents where you have to scroll down about 5 pages before you find one to control some kind of visibility that has an obscure name. We need the functionality to be able to, for people to be able to switch these doors out or switch these subcomponents out without breaking the families. So we use shared parameters for that. We try to make the naming of the actual parameters as simple as possible, and we embed like classification information as well. So that leads nicely onto the kind of the data side of it. We don't put all the data parameters inside the families because in majority of instances we don't need to, because a lot of it is very project specific. So what we do load inside the families, we've got things like IFC data that we want to encourage people to use across the board. We have some classification data, so NRM1 and Uniclass systems and element parameters. We try to avoid using the product classifications from Uniclass just because it's a little too detailed. In the majority of instances it's very difficult to actually find the one that's appropriate to that door set that you're actually building. And then the basic kind of description information as well. So that's the kind of core stuff that doesn't change from different doors within that family. And then you've got project specific information, stuff that will change on a regular basis, so such as the finishes, which ironmongery sets, what details you want to use, any Kobe information and where the door is. So all that information sits inside the project, and a lot of the time, well, in all instances, all this kind of stuff just sits inside as a project share parameter, and then is added into our schedules there. So essential know-how. So you've got to be realistic. It's going to be unavoidable that you'll need to make changes to this content further down the line. But to speed it up, you can use things like anybody who's building content on their own, I can't recommend this enough, the CTC BIM Managers suite. Certainly the family processor tool within there. It's not that cheap. It's not like one of your $10 kind of plugins that you can get off the Exchange store. I think it's about £1,500 a year. But to be honest, if you're building a library like the sort of library that I've built there, it's an essential tool. So this is just like one of the screens of stuff that you can do. So you can pre-populate your families with all this data. You can select what data you want to import and stuff like that, and you can say, right, open every single file and push all this information into that. You can get it to switch parameters out, rename parameters, add materials, and purge them, which is quite handy as well. I'm not a salesperson for this product. It may sound like it, but it's a really, really great tool. It's one of the best ones that we've got. Set up keyboard shortcuts might sound like a bit of a no-brainer, but if you're doing the same thing, if you have to open every single one of your families to make a change, and you're making the same change because you've already built all the content, which has happened to me several times, So you start off with this ideal seed family, you've only got one, and then you build it from there, and you think that seed family is perfect, and then you build a few more and you think, darn it, I've got to make changes. So you make changes across there, and then you roll it out across the practice and realise you've got to make changes again, and that's the point where you've got to change everything. So if you're going through 190 different doors, then you want to do it as quickly as possible. So using things like keyboard shortcuts and pulling out panels from the ribbon so they're stuck on the screen, so you don't have to worry about clicking tabs, it saves those valuable seconds. So do's and don'ts, kind of, there's a few things that I won't really cover too much in detail, but do use subcategories. Definitely recommend this to control the visibility of content inside your projects. So being able to turn off your swings in plans, in elevations, being able to change the line appearances as well, really useful and handy. And then align the naming to align the naming to industry standards. I think I've got these a little bit mixed up. What's that one for? Okay, that one is he's not on there. Okay, right. So another issue as well is if you have instance parameters, length parameters, and you load them into your project and they're controlled by formulas and bits and pieces. Sometimes you do get the grip inside your project, and you'll always get one smart guy who says, "Oh, what does this do?" Pull it, and then it breaks your family. So the best thing to do instead is any reference plane that it's a bit of a tips and tricks for you. Any reference plane that connects to that you don't want to see. If you change it to not a reference, then that little grip won't appear inside the project. So that's a real handy one. I haven't got an example for you for the angular constraints, but those are a real pain in the ass. Ever had a door where you've turned it to 190 degrees and then turned it back again and it's flipped the other way around? Well, there are ways around that by using calculated values and bits and pieces, but let's see what else we've got. Move all your there you go. That's the naming. Try to align your naming to a national standard. You don't want to get on a project where you're having to rename everything or rename all your content because somebody's wrote inside the BEP that you have to align yourself to 8541. You might as well just do it with inside your library standards as well. Calculated fields, so any calculations that you've got, move them away from all the other stuff, so it just makes it neater for people inside the projects. So I tend to move all mine down to general and just use things like construction and dimensions for the majority of the kind of functionality. Because you know that people just aren't going to scroll down looking for stuff, and they'll say, "Oh, how do you do this instead?" Use shared nested, don't use not shared, and don't make assumptions of what people want. I always advise doing like a stakeholder group at the start, pull people in, understand what kind of functionality people need, what sort of visibility controls. Just see examples of historic drawings that people have produced and sort of level of detail that you actually go to with the doors, and then consider whether that's appropriate inside a family. Does it need to be 2D, or can you actually be 3D instead? And then this last one kind of popped up in 2019, and if you've dimensioned to any geometry, when you open family in 2019, it warns you, says it's not good practice. So we kind of changed the way we built our content, not because of this, but we completely overhauled our kind of content. So plan and prototype, as I kind of talked about earlier on. Start off with your initial ones, build it, test it, get stakeholders involved to have a play around with it. Don't be too precious about your content. Don't fight back with the guys in the office that says, I want it to be controlled by structural openings as opposed to leaf sizes, because that's the way you spent 5 hours setting it up, or 2 weeks. Because the amount of time that you spent building that content is insignificant against the amount of time that people will benefit having it built the right way within the offices. So make sure you listen to them and build it how they want it. No library is perfect. The library that we have now is the 4th iteration of this for me. I recently rebuilt it from the ground up, which was a mind-numbing task, but it's something that you have to do. Like doors, windows, if you're architects, then it's your bread and butter. It's the sort of content that gets used every single day, every single project. So having that right just means that you can get new people that have been maybe gone on a 2-day training course that can jump straight in, grab your content and use it, and then make drawings that look great. One thing as well is the size of the content, the file size of the content is less important for me rather than the complexity of the geometry itself, and like how much kind of detail you see in plan and in elevations, because that's what ultimately affects performance. It goes back to what I was talking about earlier, just a few moments ago, about the performance of the time taken for me to make changes against the benefits that everyone else experiences. It's a similar thing with this. If you have loads of content, it takes a while to open the file, but once it's open, if it's really low in complexity, then switching between views is really fast. And that's what people do more than open files. Whereas if you have really small stuff that is really complex, has loads of curves, you see like voids in 3D and stuff like that, and in elevations, all that needs to be computed when you switch views, and that ends up being a bottleneck for your users and really slows it down. So opening elevations, opening your big GAs if you're not controlling your levels of detail, and that's the sort of thing that'll get you brownie points if it's fast. And that's us, and that's it.